Hi everyone. So today we're going to be starting a new topic called polar coordinates, and we'll see that this is related to trigonometry, but it's pretty much its own separate topic. We're really kind of moving on from trigonometry at this point. So we'll be talking about polar coordinates today as well as tomorrow and the next day in those videos. So what are polar coordinates? So we'll see that basically polar coordinates are another way of describing a point. So currently, when we're talking about a point, like a point that lies on a graph, if you're sketching a graph, we give the x coordinate and the y coordinate, right? So we have this system where we basically say, what's the horizontal distance and what's the vertical distance? And so that system is called rectangular coordinates. So for example, you might have a point with coordinates 4, 3. So if you have a point that has coordinates 4, 3, I think we all kind of just take that for granted. We've seen, ever since you started learning about graphs, you've learned about these x and y coordinates. What do they really mean? Well, the x coordinate is a horizontal distance. And let me make that a little neater. So x coordinate is this horizontal distance, and the y coordinate is a vertical distance. And so that's why it's called rectangular coordinates, because you're kind of measuring in this rectangular way, right? You're seeing how far do you have to go over, how far do you have to go up. It kind of forms this rectangle. So I want to kind of give an analogy that will maybe help us think about what polar coordinates are like. So let's say that you are in a city and you're trying to kind of travel from one point to another. So let's say that you are starting at the origin here. So how would you think about getting to this point 4, 3? Well, you could think of it as you're going 4 blocks to the right, or let's say 4 blocks, that would be east, and 3 blocks north, right? 4, 3 means you have to go 4 blocks east, 3 blocks north. So that's one way of describing where a point is, right? Or describing where, in this case, where maybe your friend's house is in a city that you're trying to get to, is you can describe how far over, how far up, or how far east, how far north do you have to go. But another way that you can think of describing this point and where it is you could think about how far is it? So like, what's the actual distance from the starting point until the point you're trying to go to? But that's not quite enough information, right? Like just knowing what the distance is doesn't tell you where that point is, because the point could also be at that same distance over here, or it could be at that same distance over here. The distance doesn't quite give you enough information to tell you exactly where that point is located. So what information do we need to add in order to really like uniquely locate that point? Well, we need to know the distance, and then we also need to know this angle. And so that's going to be really the format of writing down polar coordinates is we're going to write down the distance, which we'll call r, and you can kind of think of it as being like a radius, and then we'll also write down an angle, theta. So let me write that down now as our definition for polar coordinates. And in tomorrow's video, we'll get into translating between rectangular and polar coordinates. So we'll do examples basically like the one that we have here. For now, I'm not going to tell you what the polar coordinates are for this specific point. We'll come back to that idea tomorrow. For now, we're just going to be talking about like what polar coordinates mean and do some examples of graphing points in polar coordinates. So how do polar coordinates work? Well, basically, if you're trying to describe where a point is in space, as we said earlier, instead of giving the horizontal and vertical distance to that point, you just give the direct distance to that point. And then you also need to measure what is the angle that it takes to go from the x-axis to the radius that you just sketched, or that orange line that you just sketched. And so let's call that line, that radius r, and let's call this angle theta. And so the polar coordinates of this point would be r, theta. So it's like the two pieces of information that you're giving to locate the point, instead of it being an x coordinate and a y coordinate, it's a distance and an angle. So I want to basically just do a bunch of examples of graphing points. So basically just taking a point that's given in polar coordinates and figuring out like where does that point lie. And then we'll see that with polar coordinates, there's actually more than one way to describe a given point. And so that's the other thing we'll be focusing on in this video. So when you're graphing polar coordinates, one thing I just want to kind of emphasize, so let's say that you had, a grid, something like this, and you were asked to graph the point, and we'll get into an example like this in just a second, but let's say you were asked to graph the point 2, 2 pi over 3. So that would mean that you want to go to an angle of 2 pi over 3. So that would be like this, right? 2 pi over 3 would be an angle like over here. But the point that I'm trying to make with this sketch here is that it wouldn't be exactly clear like where a distance of 2 is, right? Like we don't really know how to measure diagonally. The way that axes are usually set up is they'll have units like this, 1, 2, 3, 4, but that doesn't tell us diagonal distances. So I want to show you that basically we're going to be, when we're graphing these kinds of points, we're not going to be graphing them on grids that look like the usual XY coordinate grids, because those just aren't very useful for graphing polar coordinates. Instead, we're going to be graphing them on grids that look like this. And I know this probably looks kind of overwhelming, but how can you interpret this? Well, basically, let's do the example I just mentioned. So let's actually sketch the point. So we're going to graph the point. 2, 2 pi over 3. So that tells us that we want to go to an angle of 2 pi over 3. So it's very faint, but you can see that here it says 2 pi over 3, but you also know where 2 pi over 3 is yourself, so you shouldn't have to look at that guideline. So we go to our angle of 2 pi over 3, and so that tells us we know that the point that we're trying to graph lies on this point, or on this line. And so notice that there's like these concentric circles. Those are telling us the distance. So if you think about it, all of the points that are a distance of 1 from the origin are going to be in a circle, right? That's like the definition of a circle. A circle is all the points of a fixed distance. So if you were to take like a string with a distance of 1 and kind of drag it all the way around, you would get a circle, right? That's like how a compass works. And so so anytime you're graphing polar coordinates, you're going to be using this kind of polar graph paper, basically, where instead of counting your distances as boxes, you're counting them as circles. So in this case, we would go to our angle of 2 pi over 3. And so we know that that again is where I just had it drawn. And then we would say, okay, where's a distance of 2? Okay, it's right here. And so this would be the point 2, 2 pi over 3. And by the way, so Desmos, you can set it up to graph things with polar grids. I just want to quickly show you how that works. So typically when you first go into Desmos, it looks like this, right? So if you go to the graph settings button and then you click on, there's like 2 different options for grid. If you just click on the one on the right, it'll give you a polar grid. One thing that's kind of unfortunate is that it actually doesn't allow you to plot points. So if I were to type in the point that we just did, 2 pi over 3, 2, nothing would show up. It's just, I don't really know why, but there's just some limitations to basically the things that you can graph. But we'll see in the video, possibly tomorrow, definitely on Friday's video, that one of the nice things about polar coordinates is that if you write down equations using r and theta instead of using x and y, you can get really interesting shapes. So using Desmos, you can graph things like this. So this is the graph, r is equal to cosine of 4 theta. So we'll get back to really interpreting what that means another time, but I just wanted to quickly show you that so that you can kind of have some idea of like why we're even talking about polar coordinates. So one of the main reasons is that once you have polar coordinates, you can then write polar equations that can give you really cool, interesting graphs like this. Okay, so let's graph. We're going to graph a few more points, and then we'll do one other thing with those points. So let's now graph Did I say graph or plot? I said graph the point. So now we're going to graph the point. -3 negative pi over 6. So I always kind of wish that these two numbers were flipped, but they're not. You always give r first and then theta, but really you want to look at theta first because that kind of tells you where on the, what direction to go. So we can go to an angle of negative pi over 6, and here that's written as 11 pi over 6, but we know those angles are coterminal. So we can go to our angle of negative pi over 6, and then we're supposed to go a distance of 3. And so here would be a distance of 1, here would be a distance of 2, this is a distance of 3. So this would be our point. Okay, so next thing I want to look at is graphing points where the r value is actually negative. So I want to look next at graphing the point. Why is this not moving? There we go. So next I want to look at graphing the point let's do -2 pi over 3. So we previously, on the last page, we did 2 pi over 3. That was this point here. And now we're going to do -2 pi over 3. So what does it mean to have a negative number for the r value? It basically means that you go the opposite direction when you go to plot the point. So what do I mean by that? So we basically go to the angle of 2 pi over 3, right? So we know that that's going to be this angle. And if it was +2, then we would be going to this point here. But it's not, it's -2. And so what that tells us is that we actually want to, while staying in the same direction, we want to go 2 in the opposite direction while staying on this same angle. So if we were to continue this angle, it would be like that, right? This is the same kind of line going through the origin. And so instead of going in this direction for our positive angle or positive radius, we're going to go in this direction. So the point would be here. So you still kind of use the angle to kind of get your bearings to figure out what direction you're going, and then you figure out whether the radius is positive or negative and use that to tell you, do I want to go kind of in the positive direction or in the negative direction? So if it's positive, you're basically going along exactly where you drew the angle in the first place. If it's in the negative direction, that's where then you need to kind of extend your angle and go in that direction instead. So this would be our point. So I just want to add that to our initial kind of definition of polar coordinates. So this would be the case where r is positive. And I just want to sketch a picture of what it would look like if r was negative. So if instead you had a negative r value, and let's say it was like the same angle, it would end up looking something like this. So if this was your angle theta, but your r was a negative number, then that would mean that instead of going in this direction, in the positive direction, you would go in the opposite direction. So this would be the point negative r theta. And this would still be, like, basically this is a distance of r, it's just that it's the distance but in the negative direction instead of the positive direction. So this is, or I shouldn't say, never mind. I mean, basically we put a negative sign there, so I shouldn't say r is negative, right? Because that would then mean that negative r is positive. So I'll just leave that as is. Okay, let's do one more example where we have a negative radius. So let's do now, so same one that we did on the previous page, but now with a negative radius. So let's graph the point. So now it's going to be -3. And actually I lied. We're going to do a slightly different point. We're going to do -5 pi over 6. So first thing we want to do is just go to that angle. So where is negative 5 pi over 6? Well, that means that we're going to be over here. So this is our angle. So if we were doing positive 3, negative 5 pi over 6, then our point would be here. Because that's the direction that kind of points in the direction that the angle is already going, right? This is like the direction of the angle, negative 5 pi over 6. But we have a negative radius. And so what that means is we want to extend our angle kind of across the origin. And instead of putting our point in that positive direction, we're going to put it in the negative direction. So we want to put it again on the circle with a length of 3 or a distance of 3. And so that would be here. Okay, so one thing that you might notice is that for all of these points we graphed, there are different ways that you could have described this point. So like, for example, the point that we have here, instead of describing it as negative 3, negative 5 pi over 6, you actually could have said positive 3, positive pi over 6, right? Because if you were to go to an angle of pi over 6 in the positive direction and go a distance of 3, that would give you the same point. So the next thing I want to do is basically go back through all of the points that we graphed and write down a couple of other different ways to represent that same point. So another way to describe this point. And I guess we're going to do like 2 ways for each of them, but whatever. So how else could we describe this point? So the way that we described it initially was 2 pi over 3. So one way that you can always find a different description for that same point is by finding an angle that is coterminal with the angle given. So another way that we could have described this point would be, so if we were to, instead of measuring the angle this way, so that's an angle of 2 pi over 3, if we measured the angle, and maybe let me just write that down. If we were to measure the angle instead like this as a negative angle, it would then be, let's see, what would it be? So we'd have negative pi over 3, negative 2 pi over 3, negative 3 pi over 3, it would be negative 4 pi over 3. And sorry, I wrote this in the wrong order. I always want to put the angle first, but it's the radius first. So that would be another way to describe this point. And let me write down that angle here. So yeah, so basically what am I saying with this example? I'm saying that if you leave the radius the same and you just replace the angle with a different coterminal angle with your original angle, it's going to be the same point, right? Because coterminal angles point in the same direction. It doesn't really matter how you got there. When you're graphing a point in polar coordinates, you really just care like what direction is that angle pointing in. But we could also even describe it a different way. So, and you could come up with other different coterminal angles. Like you could also say, so 2 pi over 3 plus 2 pi would give you, I think, 8 pi over 3. So you could also say 8 pi over 3 or 2 comma 8 pi over 3. That would also work. But you can also find a way to do it with a negative radius. And this is a little trickier. But if we wanted to write down our point with a negative radius, that would mean that instead of having the angle lie on this, right? So that angle is 2 pi over 3 or negative 4 pi over 3. If we instead had the angle that was like this. So what would be a name for this angle? Well, there's multiple names, but one angle name that we could give it is we could call it negative pi over 3. So if the angle that we gave was negative pi over 3 instead, then how would we get to this, this point? Well, then we would have to have the radius be negative 2, right? Because if our angle is negative pi over 3, that means the default is to point in this direction. And our point is not in that direction. Our point we know is here. And so in order to get to that point, we would need to then specify that it's -2. So let's do a similar idea for these other ones. So again, we want to find two different ways to describe this point, and I'm going to change it to black so that we can kind of have multiple things going on here. So how was the way that this was initially described? Well, we were describing it with, this was our angle, and we're describing this angle as -pi/6. So one other way that we could describe this point is we could just find a coterminal angle. So instead of describing this first angle as -pi/6, we could describe it as 11pi/6. So if we were to do that, our point would still have a radius of 3. So r is still 3, and then we would just change the angle to 11pi/6 because it's still the same angle, it's still pointing the same direction, it's still the same distance, it's still in the positive direction in that direction. What if we wanted to make the radius negative? So if we wanted to make the radius negative, that would mean that we would need to have the angle go kind of across from it, right? We would need this angle, because if this was our original angle, and so what is that angle? That angle would be 5pi/6. So if our angle was 5pi/6, well, if we did 5pi/6 with a positive radius, that would put the point over here, right? And that's not where we want it. We want it in the other direction. So we would need to say -3. So in general, because there's always multiple ways to write a point, you kind of have your choice. Generally, I think it's easier to use a positive radius. So I think probably the most natural way to describe the point that we have here would probably be either of the two that we did in green. So either -pi/6 or 11pi/6, either of those is totally fine, and then together with the positive radius. So let's look at the two that we did with negative radii, and we can, for each of those, figure out how to rewrite them with positive radii. So I'll change this color again, and so this was 2pi/3. So this one, we basically were going to an angle of 2pi/3. So this was the positive direction. But then because it was negative, we went away from that, right? We went like away from that angle that we had initially sketched. So first let's write down a coterminal different way of describing this. So what would be an angle that's coterminal with 2pi/3? Well, one example would be if we measured it like this instead. So that would be -4pi/3. And then the radius would still be -2, because if you go to an angle of -4pi/3, you're still pointing in this same direction. And so if you want to get the point that's over here, you still would need to use a negative radius. However, if we wanted to make a positive radius, well, then we could just instead measure the angle this way. So if we measure the angle this way, then that would give us -pi/3. And so if you were to go to an angle of -pi/3, that would put you pointing in this direction. And so then we could make the radius positive because it would be in the same direction as the angle that we wrote down. And let me just write this angle down too. So if we were to use the green way that we wrote down there, we would have +2 -pi/3. So it's really just kind of when you draw your first angle, it's like, are you going towards or away from where that angle is pointing? If you're going towards it, then that's a positive r. If you're going away from it, then it's a negative r. So last example here. So again, let's first do one that is still a negative radius, and then we'll do one with a positive radius. So where did this angle come, or where did this point come from? It came from the fact that here was our angle of -5pi/6, right? This is an angle of -5pi/6. And then rather than going in the same direction as that angle, we went away. We went in the opposite direction. And so that's because of that negative sign. That's why we ended up with the point over here instead of, over here. So another way of describing this angle, negative 5 pi over 6, would be to measure it now this way. So if we measured it this way, it would be 7 pi over 6. So an equivalent way of writing down this point would be, again, negative 3 and 7 pi over 6. Because if you go to an angle of 7 pi over 6, that's still going to be pointing in this direction, right? It's still going to look the same as this initial angle. And so that means that we would, in order to get to this point, we would need a negative radius so that we would be going in the opposite direction. Okay, so now let's try to describe this point with a positive r. So in order to get a positive r, that would mean that instead of getting this angle here, we would want our angle to actually be in the direction where this point is. And so we want this angle. So if we wanted that angle, we could measure that as just being pi over 6. And so that would give us pi over 6 as our angle, and then the radius would be positive 3, because now the direction that the point is in agrees with the direction where the angle is pointing rather than away from it. Okay, so that's basically it for today. So like I said, in tomorrow's video, we'll talk about how you can go back and forth between polar and rectangular coordinates. And then we'll, in Friday's video, get into actually graphing some polar equations and seeing how you can get cool things like that, that flower that I showed you earlier. All right, I will see you all next time.